Agradezco mucho el comité organizador para invitarme a hablar con ustedes. Y estoy especialmente entusiasmado con el tema de ese congreso. It seems to me that the theme of this Congress, responding to rapid environmental change, is one of the biggest challenges facing society today. Throughout human evolution, people have always had to deal with change, so that part's not new. You can see in the bottom here that there were huge changes in temperature throughout the last glacial cycle. And during the last 10,000 years, on the right, you can see that it was not only warmer than during the glacial period, but the temperatures were incredibly stable and uniform throughout that period of time. And if we take a closer look on the top at the last 1,300 years of the Holocene, you can see that even the very small changes, such as the medieval warm period and the Little Ice Age, you can see that those changes were very small, and yet those had huge impacts on society and on ecosystems. And then at the very right, with that dark line, you can see that we're leaving this zone of Holocene stability. And we don't know all of the consequences of that. But responding to rapid environmental change is going to be something that society will face to a greater and greater extent over the coming years. We know many of the causes and consequences of this. We know that some of the drivers, such as changes in population, wealth, and use of resources, are increasing. This causes changes in the environment. For example, changes in atmospheric CO2, temperature, and frequency of floods. And this is associated with many other ecological changes of tremendous importance, including land use change, species extinctions, exploitation of fisheries, etc. So you can see that these things are changing, but that they're changing particularly rapidly over the last 50 years and are projected to continue, and most of these changes are projected to continue to increase. So I think we need to build a science of people with nature and a society that recognizes its role and responsibilities as part of nature. So as ecologists, we're used to thinking about the left side of this diagram, about ecological processes and their interaction with disturbance, environment, resources, and the species that compose it. And social scientists are very good at understanding the right-hand side of this diagram in terms of the social processes. We also know that ecosystem services, which are the benefits that society gains from ecosystems, are incredibly important to society, and also that society's actions has large effect on ecosystems. So I think it's important not only that we understand the ecology in that left-hand circle, but that we begin thinking of this as a social-ecological system of which human actions are a part, and so that our role is not only to understand the nature of ecology, but also to understand the nature of these interactions of people as part of nature. And I think the question is not whether the Earth is going to transform or not. This is already happening. It's more a question of whether we deliberately shape the transformations that are occurring and shape a transformation towards sustainability, or whether we let transformation happen to us in ways that are not entirely pleasant. So how do we fix a degrading biosphere? It's a very large challenge, and it's something that we need to act on now. We can't wait until the science is ready, until we know enough to be able to do this with certainty. Also, it isn't somebody else's problems. With these large environmental changes, it's clear that ecology is right at the core of these issues, and we need to use what we understand currently about ecology and about the ecology of people as part of nature in order to seek solutions. So we need to improve our basic understanding of social-ecological processes and use this understanding to explore solutions to many of these issues. It's also clearly a set of issues that's much broader than ecology. So we need to do this in collaboration with many other disciplines and with practitioners. So Earth Stewardship is an initiative that was begun by the Ecological Society of America a year or two ago. And one of the reasons I'm particularly excited about participating in this Congress is that I'd like to explore ways in which the Ecological Society of America can work with ecological societies in Europe and with the European Ecological Federation to find ways that we can work more effectively as ecologists to address these social ecological issues. And the issues are to reorient society's relationship to the biosphere, while at the same time recognizing that there's many things that are happening that will be difficult or impossible to reverse. We're already committed to a considerably warmer planet. But the fact that things are changing so quickly means that there's many opportunities for progress. There's many interesting questions and needs. And so I think there's a role for each of us as a scientist and a citizen to play a constructive role in addressing the stewardship of our planet. By Earth Stewardship, I mean the active shaping of pathways of change in social ecological systems to enhance ecosystem resilience and human well-being. So there's several features about this definition that I think are important. First of all, it entails active intervention in social ecological systems. Anytime we actively intervene in nature, it's inevitably going to be risky because we don't know enough to act with certainty. And so it's best justified at local scales where the consequences will not, where the consequences of any misjudgments will not be too serious. It involves shaping change. It involves, as I said before, a system in which people are part of nature rather than separate from it. And it has two goals that I think are equally important. One is ecosystem resilience, and the other is human well-being. So it's not an issue of people or nature, but it's a question of understanding the science of people with nature, people as part of nature. Sustainability needs to be our guiding principle, but we need to think about sustainability carefully. We often think of sustainability as keeping things the same, and that's clearly not possible. So we need to maintain or improve ecological integrity, and we need to maintain or enhance human well-being for all segments of society. So, and it involves shaping the future rather than reconstructing the past. So I think we can use what we understand about sustainability and use this as a guide. So we can use ecological integrity and human well-being as guides towards stewardship. And it also provides a new context for issues of restoration and remediation because it's shaping things in a way that'll be compatible with the goals of sustainability and human well-being under future conditions. So there's two broad elements to this strategy of Earth stewardship. One is to build the science, which we're well poised to do as part of the scientific community. And it's also an issue of applying this science of sustainability and stewardship to sustainability issues. In terms of building the science, we first need to define what the scientific needs are, and as I said, it's basically about the issue, the science of people with nature. And then identify scenarios of change and intervention points in those scenarios so we can think about ways in which we can proactively shape the future rather than simply respond to changes that have already occurred. Many of the global changes that are occurring are the aggregate result of local events. And since each of us understands our local place and we play a role in the society and politics of those local places, we each have an opportunity to act in a situation where we're already well informed about the issues and the processes that are occurring. And so I think many of us already have the skills and knowledge necessary to apply our current understanding to solutions. What I'd like to talk about today are some examples from Alaska, and then some globally, some other examples that occur frequently throughout the world. In Alaska, over the last 30 or 40 years, you can see in the black line on the left that temperature has increased, and that it's projected to continue increasing. You can see that there's a lot of variability, both in historical and in projected temperatures. But just to give you a sense of what this means, we're familiar with, each of us is familiar with what it means to experience an unusually warm or an unusually cold year. And by mid-century, which is only 40 years from now, the projections are that the average temperature will be similar to the warmest years that we've experienced historically in Alaska. And by the end of the century, the projections are that the coolest years will be similar to the warmest years that we've experienced historically. So each of you understands and has a good sense of what it means to experience an unusually warm or cold condition. So this gives you a sense of what an impersonal graph like this really implies to people and to ecosystems. One of the things that's happening in Alaska already is that the sea ice is retreating, and this has consequences for ice-dependent marine mammals. In 2007, for the first year, walruses abandoned their sea ice platforms, which they use as for feeding and nursing, and went to shore because the ice was retreating north of the shelf break, so that the water was too deep for the walruses to be able to feed on the bottom. And so they had to abandon that and feed from shore. So this tremendously changes the ecology of walruses. And since 2007, this has happened 3 times. And the projections are that we could be seeing an ice-free Arctic within the next few decades. There's also many coastal communities in Alaska whose culture and nutrition are tightly tied to the hunting of marine mammals. And so this certainly has strong implications for them as well. The area burned in western North America has doubled in the last 40 years. That's a large change in disturbance regime. In Alaska, one of the changes that's happened after fire is that the fires have burned much more deeply and have burned away much more of the organic mat. You can see a typical post-fire scene in the lower left, where the trees which are rooted in the dead organic matter remain standing, and most of the sprouting vegetation resprouts from stems that were present after the fire. On the right, you can see that most of the trees have fallen down, and that it's a very different vegetation that returns. The figure on the right is typical of many of the fires that have occurred in the last decade or so. The fires are burning much more deeply. One of the things that happens then is that because it burns away the organic mat, small seeded deciduous trees are able to establish in areas where they never were able to establish before. And typically in these forests, all of the trees that establish do so in the first decade after a fire. And so you can, by looking at the initial patterns of establishment, you can tell what the vegetation trajectory is going to be for the next century or century and a half. And so we already know by looking at these post-fire sites that we're going to see a widespread shift from a conifer-dominated biome to a biome that's dominated by deciduous forests. That has huge ecological implications for just about anything that any of you might care to study. here there's two maps. The map on the left is a map of the ecosystems of Alaska, with each color representing a different kind of ecosystem. And the map on the right is the language groups of Alaska, the indigenous language groups. And you can see that these maps are virtually identical. And this is because indigenous cultures in Alaska are tightly tuned to the natural environment and have affected their environment in ways that are representative of each particular culture. So for me, one of the big issues with ecological change is, what does this mean for culture? If we know that these cultures are tightly tuned to their ecology, so if we're changing the ecology as radically as we're seeing, what does this mean for the cultures of people who've lived in this place for thousands of years? My colleagues and I have been working with communities to get their perspective on these issues. One of the issues that we've been studying is changes in fire regime. And so we've been talking with local communities about issues of fire risk. And they're concerned about that, but their bigger concern is that the cost of fuel to heat their homes, to heat public buildings, to run their snow machines and boats, it costs about twice what it does in Fairbanks, where I live, because these communities have no roads, so they have to either bring in by barge or bring in by airplane all of the fuel. So here's an area that it's the most extensive area of poverty in the United States, and they have some of the highest fuel costs in North America. And so they're concerned about what this means for the viability of their communities. And so one of the things we've talked about is whether there's ways in which the black spruce forests which surround their communities and which account for the fire risk could be used as a fuel for heating homes. And so we worked with them and find that this is ecologically sustainable for 90% of the communities in interior Alaska. It's economically viable, and perhaps most importantly, 90% of the cost of harvesting this fuel is retained locally as wages, so it would support the local economy. And also by providing early successional habitat, it would provide better habitat for moose, so people wouldn't need to travel as far to hunt. So this is an example of the way in which I think we can blend together some of our understanding of ecology with local understanding of the issues that people face and the environment as they see it. This is a map of the hunting routes of people who live in Venati, which is a small Athabascan Indian village in interior Alaska. The green is the routes that people have taken in the last 10 years, and the gray is the lifetime routes that hunters have taken over the course of their lifetime. This is a map of climate projections for summer temperatures. The current temperatures in the upper right, then at the upper left, the mid-century, and lower right, the end of the century. And you can see that it's likely to become warmer, as I showed earlier. But it also shows that we can use downscale climate projections to begin to inform the issues that communities are facing locally. So we can take the map of current temperatures on the left here around the community of Venati and project those to 50 years, what it's likely to look like 50 years from now. And then we can begin talking to local hunters and elders about what particular temperature regimes mean to them as they're out on the land hunting and trying to get around the land. So in terms of moose, the local people think that fires are likely they can tell us what temperatures mean for moose, and they can tell us what fires mean for moose. And it's likely that fires will initially displace moose, but that they'll return fairly quickly, and that fires are likely to be good for moose. However, caribou avoid burns, so it's likely that caribou herds which migrate through this area in the wintertime might well be inaccessible to hunters from the village. Fires also destroy the trails that people use for hunting because the trees fall over, as I showed you in one of those earlier pictures, and it creates ground that's very rough for traveling. And so we can take what people understand about what local people understand about likely consequences of changes in temperature, and we can take what Western science tells us about climate change and put these together to come up with scenarios of future availability of various subsistence resources to local communities. And in general, what we've learned is that Western science has a much better capacity to predict changes in population densities, because these changes in population densities involve processes that occur at larger scales than are experienced by local people. However, local people know much more than the scientific community about how changes in temperature, changes in snow conditions are going to affect the distribution of subsistence resources on the landscape, and they also know much more about the factors that will influence the capacity of people to get out on the landscape to access these resources. So putting these things together, I think we can come up with, and working with local communities, I think we can come up with a good understanding of how things are likely to change, what it means to local people, and then explore with them what their ideas are about potential solutions. I think each of us could do this in our own local place for issues that are important to people where we live. There's also a set of issues that we know are important globally, and that ecologists, I think, are well poised to contribute to. Transformation of cities is something that's happening globally, probably more rapidly than any time in the past, and we're setting in place infrastructure that'll last for at least a half century. So it's a wonderful time to become involved in shaping the future trajectory of these cities so that people interact with nature in a sustainable fashion as cities develop. We heard yesterday a lot of the issues about the future of biological diversity and things that affect that. I've already mentioned that I think that the future of cultural diversity is equally important. Meeting the needs for food and water while maintaining the conditions of the environment is a tremendous challenge everywhere. Managing uncertainty is clearly going to be a challenge because we don't know what the future is going to look like in all of its details. Finding ways to foster environmental citizenship so that people play a responsible role in shaping the changes that occur. Communicating more effectively to the science that we know to society is important. And then coming up with more effective tools for governing the global environment is a major challenge. So we need one of the challenges that I think is particularly important is managing transformations. Transformations are occurring, and many systems exist in multiple alternative states. And at times of directional environmental change, I think we're going to see increasing likelihood of passing beyond thresholds that'll lead to important transformations. There are many situations where the current situation is not entirely desirable, and we may want to think about deliberate transformations to escape from undesirable states of poverty and environmental degradation. So we need to develop a science of transformation that recognizes the symptoms and opportunities for transformation, and to develop scenarios and identify intervention points to alter these probabilities of transformation. So this is an example in the United States where opportunities for transformation existed following Hurricane Katrina in New Orleans. We can think about the drivers of change, the system dynamics that influence the response of New Orleans as a social-ecological system to to the stresses that it experienced, and then we can think about the potential outcomes. And in terms of there's at least 3 classes of outcomes we might want to consider: whether whether we can sustain and whether the desirable conditions of a system can persist, whether we want to actively navigate toward a transformation to some alternative state, such as reconceptualizing the way in which coastal cities might be situated and function, or we might attempt to do, we might have some transformation occur that's unintended. And so the drivers of change in New Orleans over the long term have been increased hurricane intensity, land subsidence associated with land use change. Together these interacted to produce flooding. The impacts that this flooding had were very strongly determined by the properties of that social ecological system, by its various forms of capital, by the dynamics of that social ecological system. And then as a result of the impacts, we have opportunities to learn, cope, innovate, and adapt. And these actions that we take influence the likely outcomes. So we can think about many of the issues that are associated with transformations within this type of context, and thinking about the vulnerability, the adaptability, and the resilience of these systems. Meeting food needs of a growing population at the same time as meeting the environmental needs is a real challenge. We know that agriculture and fisheries must essentially double their production this century. Biofuels production is increasing food prices and demands for land. Most of the world's estuaries now have dead zones as a result of excessive nutrient runoff. So we need to develop a technology that manages nutrient inputs to crops to match those requirements so that there aren't these excesses that run into aquatic systems. And we need to develop a better system of managing riparian zones to filter those nutrients that do leave aquatic lands. So clearly, nutrient runoff has large effects on aquatic systems. These systems these consequences extend well beyond the location where the farming occurs. In many cases, we export these problems so that the problems of meeting food needs in developed nations and the needs for biofuels have ecological consequences far beyond the regions where in other regions. So I think many of you already know a lot of the details about how to build the science for stewardship. But I think we also have a role in thinking about how to apply the science to sustainability issues. And at least 2 parts of this are engaging key stakeholders and communicating the science that's needed to support a social movement. We not only need to know how to move towards sustainability, we need to make it happen. So in terms of engaging strategic stakeholders, we probably can never get everybody to be a environmentally responsible citizen. So we need to think, what are the strategic stakeholders that will really make a difference? And several of these, I think, are worth paying particular attention to. I think students with whom we all interact on a regular basis are some of the key people to involve in these issues. They have the passion to really make the changes happen, and it's their world. They're the ones that are going to suffer the consequences if we don't move towards a more sustainable trajectory. Religious communities are another group that I think are well worth tapping into, at least in the United States, and I think it's probably true in Europe and many places. There's there's already a very strong stewardship ethic that's an integral part of religious thinking. We've begun working with religious leaders, environmentally oriented religious groups in the United States, and they're very interested in partnering with sciences because they feel that scientists have looked down their noses at religious groups and that they don't have the access to science that they would like to have. So there's tremendous opportunities for engagement and partnership with religious groups, I think. Businesses are another group that have become increasingly aware of sustainability and of the potential profits that come from engaging in sustainability. Practitioners and policymakers are another group that's very important to engage with. As Jose Jimenez said in his opening remarks yesterday, this needs to be a dialogue about with stakeholders about their concerns. As a scientific community, we need to listen more about what the concerns are of stakeholders and design our science so that it meets these the needs of stakeholders rather than just the things that are logical outcomes of the science that we do on a day-to-day basis. I think it's an important time to focus on solutions more than on problems. And one of the things that I found really intriguing in talking to social psychologists is the extent to which problem-focused presentation of information tends to cause people to disengage, to feel guilty, to be afraid of what's going to happen, and to disengage from these issues and avoid thinking about them. Whereas if the same issues are presented as opportunities to make things better, people feel engaged, empowered, and are much more willing to take on the issues as part of their world. Eventually, I think we need to create a social movement. So science needs to become more action-oriented. The scientific community is probably not the right group to do this, which is why it's so important to engage leaders in other groups, such as religious communities, who may be able to convey these messages more effectively and to engage more directly in social movements. But I think we can do a lot to empower student and public leaders with the information that they need to move towards sustainability. And we should think about uncertainty not just as a barrier to action, but as an opportunity to try things out. So, in conclusion, I think we can substantially improve the relationship between society and the biosphere, and Earth Stewardship provides guidelines for sustainability at a time of rapid change. And there's lots of ways in which each one of us can contribute, but it requires a commitment to seeking solutions. And I think by working together that the ecologists of the community are situated in many places around the world and have an opportunity to make changes at many scales, and especially at local scales. And so we have good opportunities to seek to move towards well-informed solutions. And I think working together we can make a difference. And we have to do it now. Muchas gracias por su atención.